Okay, we've gone over a lot of different techniques on how to forecast. There's many that we're not going to cover that's in the book. There's exponential smoothing with trend. That's also called double smoothing. There's another technique similar to decomposition method, actually called triple smoothing. We're not going to cover that one. It's not in the book. You can also just use regression, multiple regression, when it's not necessarily a time series. When our horizontal axis isn't necessarily time, but we're still trying to predict the future based on some other independent variables. But what this video is about is how to know if we have a good forecast or not. So we're going to look at metrics or statistics to measure forecast accuracy. And the book covers three. We're going to spend our time in the calculations on this one. I think this one is the one that's is the easiest to understand. It's the mean absolute percent error. So the mean absolute percent error. So let's go calculate it. So here's some data, and I went ahead and I've already generated a forecast based on exponential smoothing with alpha equal to 0.2. So again, we always initialize by saying the first forecast equals the first actual, but after that we use the formula. Here's the formula that takes alpha times the previous actual plus 1 minus alpha times the previous forecast. And I've copied that down. And notice I don't need to go, when I'm evaluating forecast accuracy, I'm actually not forecasting. What I want to do is I want to compare what happened against what we predicted happened. So let's calculate something. First of all, let's just calculate the error. Okay. And the error is just the difference between the forecast and what we said. And I'm showing it as a percent now. We don't need to show it as a percent yet. Let's just show it as a number. So you see sometimes we're spot on, which is a little bit unfair on the first one because I'm the one that did that. But after that, this is what really happened. This is what the forecast was, so I was off 600. So that's what an error is. And sometimes it's negative. That means we're below the forecast. Sometimes we're positive. It's over the forecast. So the next thing we do, if we're going to calculate a MAPE, a mean absolute percent error, is now we have to calculate the absolute value of that. So I'm going to take, this is absolute value of E, and that's easy enough to do. That formula. All that did was turn those into positives, and again, all of these, we don't need to show that many decimal points. And I don't need to go down any further than the actual data. Okay, now that's the absolute of the error, but the percent error is what we're looking for. So how do we get a percent error? Is we take the we have to take the error and divide by the actual. So we're looking at this from a relative standpoint. We're not looking at the magnitude of the error. We're looking at the magnitude of the error relative to what really happened. And from that, we also want to show it as a percent. I think that's easier to understand. So you can see for this one, we were off 600 on a 1400 actual. So that's 43% off. The next one, week 3, we were off 80 on 1,000. That's 8% off. So we've got that. And then every one of these are absolute percent errors. So to calculate the overall average, I just take the average of all these percent errors, equally weighted. And let's show a decimal or two. So with an alpha of 0.2, using exponential smoothing, the MAPE is 15.42%. Notice what I did. I only calculate a error if I have both an actual and a forecast. If I don't have both of those, I don't need to do it. So down here, once my actuals are done, there's no reason to forecast the future, even though we could. When you're calculating forecast accuracy, you always have to have an actual and a forecast. So that's how you do it. Now, how do we decide what we're going to do now? Now that we have this, we can use it to evaluate all kinds of different forecasts. We can evaluate a technique against another technique, like a moving average forecast against an exponential smoothing forecast. We could evaluate a person, so we could evaluate this forecaster against another forecaster. Maybe they're competing for an end-of-year bonus. So we've always have the actual. This could be the forecast for a particular person, and then we could do the same thing for another person to determine who was the most accurate. In this particular example, we could look at, well, what is the best alpha? So let's make this really small. And you can see my error went up. So I don't want to go smaller. What if I want to go higher? 1403, remember I started with 15.42. So when you went to point 0.3, I got 1403. That's good. Let's go to 0.4. It even got better. So let's go 0.5. Oh, it got worse. So let's look at 0.4 again. Maybe 0.35. It's getting better. 0.34, worse. 0.36, better. 0.37, worse. So it looks like a 0.36 is the best alpha. If I set my alpha equal to 0.36, my MAPE is this. So going forward, if I want to use exponential smoothing, this is probably the alpha that I should use. Thanks.